Cool. All right, hope you guys can see my screen. So hi everyone, my name's Simon from Two. Two is a B2B BNPL company, and we're representing the data science team of a couple colleagues on the call today, Joseph and James in particular. Shout out to them. And as part of the month of MLOps competition, we decided to get our feet wet with ZenML framework and build something end to end. And we're particularly interested in how ZenML can help us in the work that we do every day. And so as part of that, we decided we would build an end-to-end pipeline for both training and deployments on a subject area that's close to our heart as a data science team in fintech, which is financial fraud detection for financial transactions. And so we just ended up developing the Streamlit app, which is sort of inverted in terms of how I want to present this, because I explain how to interact with the model first, but we'll just go ahead and scroll down, explain why we made it. So I've given a bit of background on what we were trying to do here, but effectively we decided we wanted to use ZenML to give us an indication of how it would work in our day-to-day workflow. Picked up a off-the-shelf data set from Kaggle, so this is the synthetic data from a financial payment system data set, and then went ahead and developed a model. First sort of went through an ideation phase, more Jupyter Notebook based, and then sort of as we got clearer as to what features we wanted to engineer, started building a proper model, building a proper training pipeline to help us in our experimentation and training and fine-tuning. As part of that, we encoded all of the feature transformations within that pipeline and sort of already noticed how much simpler it was to iterate on that once we had ZenML's caching ability and being able to run on with remote orchestrators. And then the second part of our project was then to actually extend this to a continuous deployment pipeline. So we went ahead and extended our training pipeline and included some drift detection and a deployment trigger, and then at the end a model deployment step to Selden. So here's just an overview of the stack that we used. We were mostly working on GCP, used Evidently for data validation, MLflow for experiment tracking, and then ended up deploying on Selden. Also, using Kubernetes for orchestration, which was a fun experiment after trying it with Vertex AI. And just to give you a bit of a visual overview of what it looked like at the end. So we had our training pipeline, which was fairly simple. I hope that's sort of visible for everybody. And then the deployment pipeline was a little bit more involved. So what we actually did was we assumed that the baseline data of the data set we had from Kaggle, we sort of took a piece that we assumed was the data we had at the T0, right? And then split out another piece that we would only get later in the continuous deployment pipeline, as we would do in a more realistic scenario. And then essentially in the continuous deployment pipeline, we would detect data drift between the original baseline and the new data. And then depending on if there was data drift and if the model that we trained met some expectations with regard to model performance, would we go ahead and deploy that model to Selden on our Kubernetes cluster. So that's sort of an overview of our training and deployment pipelines. And we explained this at length sort of in this Streamlit app, but then I just want to take you guys through this front end that we built. So what we did is we built a bit of front end that would allow you to input sort of arbitrary transactions or feature values for the transactions to the model, and particularly also let you recreate historical transactions of the original data set, because we observe often in this space, it can be interesting to know how and why the model responded to particular past instances. And so generally we try and make that easy through this app. So first we have a possibility of recreating a historical transaction. So maybe I have, a transaction at 10,000, and then the feature values for the model are sort of put as the default values on these sliders. Obviously, these are our actual features for the model. In reality, if an end user was using this, it would probably be something a little bit more high level. And then we can go ahead and run off a prediction. So in this case, for this historical transaction, 10,000, 0.01% probability of being fraudulent. We could also randomize if we close the replication here. Another one, but if we then sort of create a counterfactual transaction, for example, the transaction amount, which should almost definitely lead to a fraudulent transaction. So this was something that we had a lot of fun doing and sort of gave us a lot of inspiration for our day-to-day work. And yeah, I hope that gave you a bit of an insight as to what we were doing. And thanks again to the ZenML team and all my team members for first of all putting on this competition and working with me to get it done.